In this video, we will learn about what density is and how it can affect whether objects sink or float. In a house, the host invites 5 people to attend his party. These 5 people would only be allowed in his living room, which, in this case, will be confined to this box. It doesn't seem too crowded, and his guests have enough space to move around and talk with each other. Later, he gets word that his neighbor is also having a party with 9 more guests in his house. He decides to invite them over, so instead of the initial 5 guests in the living room, there are 15 people, including the neighbor. Now, there is barely any room for movement, and the people have to touch each other to stay within the space of the box. Density is how closely packed together a substance's particles are. In this case, instead of particles, we are using people as an analogy. Which box is more dense? The one with 15 guests is more dense because there are more people within the same space of the box, making them unable to move. If solids, liquids, and gases looked like the following with their particles, which would be the least dense? Yes, gases are the least dense because the particles are not very close together compared to liquids and solids in the same amount of volume. Liquids and solids are called condensed phases, since they are dense and have their particles tightly packed near each other. Now let's look at a more quantitative problem with density. The density of gold is 19.32 grams per cubic centimeter. If we had a volume of 20 cubic centimeters of gold, what is its mass? First, looking at the units of the density of gold, we can see that it has a common mass unit of grams over 1 unit of volume, cubic centimeters. Think of density as a conversion factor, because the density of an object will always remain the same no matter how much of it you have. Even if we cut the piece of gold into halves or quarters, it will have a density of 19.32 grams per cubic centimeter, because density is the mass of only 1 cubic centimeter of the substance. Start by writing down the volume of 20 cubic centimeters. We want the volume units to cancel out, so we are only left with the mass. This means we need to multiply it by the density. How should we write the density as a conversion factor? That's right. We want to multiply 20 cubic centimeters by 19.32 grams over 1 cubic centimeter. This way, the cubic centimeters are canceled out, and we are left with grams. 20 times 19.32 equals 386.4 grams of gold. If we had the mass in the problem and needed to find the volume, we would have to multiply by 1 cubic centimeter over 19.32 grams. Because of this, the grams can cancel out, while the cubic centimeters can remain on top for our final answer. One last problem. Barry is drowning in the lake. On the shore, his friend panics and throws a log of wood towards him. Luckily, it floats on the water, and Barry can use it for support. Phew, the log saved Barry. Later on, Barry finds out that the piece of wood has a mass of 7,800 grams and a volume of 15,000 cubic centimeters. He knows the density of the water is 1 gram per cubic centimeter. What is the density of the log of wood? To find the density, we have to recall what our density units typically look like. A mass unit over a volume unit. So, for this problem, we can put the mass of 7,800 over the volume of 15,000 cubic centimeters. 7,800 divided by 15,000 is 0.52. The units will be in the same order as written in the fraction, grams over cubic centimeters. Why did the log of wood float in the water? The log of wood could float in the water because the log is less dense than the water. The log of wood has less mass present in 1 cubic centimeter, and the water has more mass present in the same 1 cubic centimeter. In general, this is the reason why lifeguards carry a rescue tube as a flotation device to help a drowning victim to shore. If the rescue tube was more dense than water, it would sink along with the victim.